What function do I apply to this number?
X to the fourth.
Yes, x to the fourth. Awesome. Good. Now remember, we start backwards. We have to differentiate the outer function. So let's differentiate the outer function. How do I differentiate the outer function? Something to the fourth power. How do I differentiate that? How do I differentiate?
It's not x to the fourth, is it?
We imagine that it's x to the fourth. How will you differentiate that? It's not. You're correct. But just imagine that it is. How will I start? We know how to differentiate x to the fourth. How do I write it?
Is it 1 over x to the fourth?
Careful. How do we differentiate x to the fourth?
Four x to the third.
4x to the third. Now forget about this because this is not what we are discussing, but for a moment just forget about it. Please apply the same procedure here.
The inner function times 4.
Not yet, not yet. We are discussing the outer function. That's why I even covered it. How do I differentiate x to the fourth?
X to the fifth.
So again, how do we differentiate x to the fourth?
You move the power in front of the x.
Exactly.
And then it's minus 1 for the
Exactly.
power that it will have.
Now I have to copy 3x squared minus 10x. To which power again?
To the third.
Excellent. So right now I have this piece. That is done. Times the inner function prime. Please differentiate the inner function. And I will put it here. We know how to differentiate. Everybody knows how to differentiate this. Anyone, please?
6x minus 10.
Thank you. This is it. We differentiated the outer function. The outer function is blah to power 4. 4 in front. Subtract 1 from the power. But that's not enough. Times the inner function prime. So that's an example of the power rule combined with the chain rule. Okay, so let's look at a few examples. I'm going to share my screen. We're going to, I hope I'm not, no, I'm not. Okay, so we're going to page 171, and let's choose from here. Anything you want. Anything you want. Not till this notation, from 1 through 32. And then we're going to get to this notation in a minute. Anyone would like to choose? Or I will. Okay, I would like to choose 19. If you don't want to choose. So f of x equals 5x plus 2 to the fourth power times 2x minus 3 to the eighth power. Not a piece of cake, not at all. Requires a lot of care here. F prime of x. What rule applies here? What is it so that I know what rule applies? Can anyone tell us what this is? Or what rule applies here? Please. Please. Can anyone tell us what this is? or what rule applies?
Product rule.
Yes, very good. It is a product. So that's why the product rule applies here. Perfect. So we have to differentiate the first function. Can anyone differentiate the first function for us? There is an inner and there is an outer. And we start with the outer. And then I'm going to copy the second function and put plus. As you know, I take attendance every class and I see something called global SHP. I don't know who this is and I won't be able to give you attendance for tonight. So please don't do that. Actually, it was my mistake by allowing a student. Okay, now it's perfect. Thank you. Good. So can anyone differentiate this? Please, anyone? Please give it a shot. We just did a similar example. This is much easier than that one.
4.
Yes, awesome. Then
8x.
I'm not done. So when you differentiate this to the fourth power, what do you have to write? I'm using this rule. 4 goes in front. Then I have to copy 5x plus 2 to which power?
The third.
Excellent. Times the inner function prime. What is the inner function prime? This. Inner function prime.
5.
Excellent. Awesome. Great job. Plus, now I copy the first one, 5x plus 2 to the fourth power. But now I have to differentiate this. How do I differentiate 2x minus 3 to the 8th power?
8.
Yes.
Um, 5x plus 2.
I already have that. So we're differentiating this piece.
2x minus 3.
Yes. To which power?
7.
Excellent. Times the inner function prime.
2.
Yes. Awesome. Great job. It is important to continue simplifying this. But let's leave it alone, or we should simplify it. I just want to move on to other examples, but let's simplify it. 4 times 5. Remember, this is a product. I can change the order. We're not distributing. This is a product. So I have 20, 5x plus 2 to the third times 2x minus 3 to the 8th. 8 times 2 is 16. And I have 5x plus 2 to the fourth, and I have a 2x minus 3 to the 7th. And now we have to factor out from these two a 4, from these a 5x plus 2 to the smallest power, which is 3, and from these, again, 2x minus 3 to the smallest power, which is 7. From 20, I took out a 4, so there is a 5 left in. These are completely out, but from 8 of those, I only took 7 out, so I have a 2x minus 3. From 16, I have a 4 out, so I have plus 4. This is completely out, but I have 4, and I removed only 3. So I have 5x plus 2. And I have to distribute here. So the final simplified form would be, it's my page 4. 4 in front, 5x plus 2 to the third, 2x minus 3 to the 7th, and now 10x minus 15 plus 20x and plus 8. So 4, 5x plus 2 to the third, 2x minus 3 to the 7th. I have 30x and then minus 7. This was a lot of work, and this is the simplified form in complete factored form. A lot of work. Okay, let's choose another. Where is my share button? Right here. Okay, so let's choose another. All of these require a lot of algebra, as you've noticed. A lot of algebra. Would you like to pick another? Or I will.
Can we do 27?
27, very good. Where is 27? I see it. Ugly, ugly, but we need to see some of these. Okay, very good pick. Thank you. H of x, 1 minus 3x over 2 minus 7x, everything to negative 5. I thought it was 3, but it is negative 5. Perfect, perfect pick. Well, when I look at this problem, I need to remember that a over b to power negative n is the same thing with b over a to power positive n. This really helps because I really don't want to work with a negative power. So then h of x is the same with 2 minus 7x over 1 minus 3x to the 5th power. So when I differentiate this, this is the inner, this is the outer. So let's start. Please try it. It's okay if you're wrong. We just looked at this for the first time. So I don't expect anyone to perfectly understand everything. So give it a shot. How do I start differentiating this? Anyone?
Are we going to multiply by 5?
No, but the idea is you're correct. We're not multiplying. We are bringing 5 in front. Then what happens? What do I have to write next?
Parenthesis?
Yes. What do I put in parentheses? Awesome.
2 minus 7.
The whole thing. Very good. Awesome. Yes. 1 minus 3x. To which power?
Is it going to be 2?
But we have this rule. We bring down 4. We subtract 1 from the power. So then,
The 4th power?
excellent, brilliant, good, times the inner function prime. How do I differentiate this? What is it? And what rule I have to apply? If I know what it is, I know what rule to apply. What is it?
The quotient rule.
Excellent. I square the denominator. Can anyone give us the derivative of the numerator so I can put it here? My marker is drying out. Please. The derivative.
-7.
Thank you very much. 1 minus 3x minus, I copy the numerator. Can anyone give us the derivative of the denominator so I can put it here?
-3.
Awesome. Great job. There is nothing I can do this to this. There is nothing I can do to this, but I have to simplify this one. So 5 outside. I'm going to separate this to the power, this to the 4th power, because I will multiply these two eventually. So 2 minus 7x to the 4th over 1 minus 3x to the 4th times 1 minus 3x squared. -7 times 1. -7 times -3x. -3 times -1, so it's +3. 3 times 2. 3 times negative 7x. Nice. Negative 7 times plus 6 is negative 1 times 5 in front. So I have negative 5. The numerator is 2 minus 7x to the 4th power. And the denominator is this times this. What is the power of 1 minus 3x? I have 1 minus 3x to the 4th times 1 minus 3x to the 2nd power. What power do I put here?
Two.
Careful. We have power 4 and we have power 2.
6.
Yes. A to the nth times a to the mth is a to n plus m. Nth plus mth. A lot of work, a lot of algebra. Let's look at a word problem now. Because we want to know why. Why are we looking at this? Why is it so important? So here are a few options and you tell me what you would like to work on. Total revenue. A total revenue function is given. Find the rate at which total revenue is changing when 20 have been sold. Total cost. Total cost again. Compound interest. So let's choose one. What are we interested in? And I'm on page 5. If you don't choose, I will. Okay, I will choose 63. 63 on page 172. In 63, we're given if $1,000 is invested at a rate, this is 1,000, rate is R, compounded quarterly, is divided by 4, as we know. 5 years, right here, 5 times 4 is given the formula. We've used it before. Find the rate of change, either A prime or dA over dr, because R is the variable, and give its units, and explain what it represents. So A of R equals 1,000, 1 plus R over 4 raised to power 20. They want us first to find in part A, dA over dr. If you don't like this notation, we can still use this one now. And then in part B, they want what it represents and the measurement unit. So, can anyone tell us how we differentiate this?